Regarding today's topic on reducing network TCO, we have had a lot of feedback from customers and partners about this topic. We're fortunate to have Rich with us to guide us through today's discussion. He has over 20 years experience helping plant engineers and OEMs increase manufacturing efficiency through automation. Rich is a big believer in the use of data to improve manufacturing processes and has served a wide range of industries, including automotive, semiconductor, food and packaging, machine tool, and textiles. Rich, let me hand it over to you.
Thanks, Oliver. So thanks for joining us today for 5 tips to reduce your industrial network total cost of ownership. So here's our agenda for today. We're going to start by just reviewing some of the current trends. Then we'll talk about some of the common challenges that we face. We'll run into some of the hidden costs that we typically find when implementing industrial networks. Then we'll talk about 5 tips to reduce those costs. And we'll wrap things up with a Q&A session at the end. So here you can see there's been several studies done by a variety of different groups on the growth of the IoT, or Internet of Things. While everyone seems to have different numbers as far as the number of connected devices and the growth rates, pretty much everyone agrees that between now and the next 5 years, we're going to see roughly a doubling of the number of connected devices. So when we talk to people, a lot of people assume that the majority of the growth in connected devices is going to be in wearable devices or home automation type applications. But what you can see based on this study from McKinsey and Company is that the vast majority of the investment and the growth in investment is actually in factories and connecting devices in the factory in order to optimize efficiency of production lines, do predictive maintenance, and get better asset utilization. So this slide kind of shows kind of the progression of IT systems and operational technology systems. And we can see over the last couple of decades that we've advanced through several layers of technology, and over the last decade or so we have seen more and more integration between IT and industrial automation control systems. And so the 5-layer model, or 5-layer architecture, starting from the I/O and PLC layers to the SCADA, the manufacturing and engineering systems, and ERP systems, is pretty much the accepted model that's used today. The big thing that we're seeing now is a move towards more cyber physical systems, where nodes within both networks connect to every other node utilizing the internet. All right, and that brings us to our first poll. So how would you describe your adoption of the industrial Internet of Things? So as we talk to people, we find a range from people that have no interest or don't even have an understanding of what IIoT could do for them, to some people that are exploring it or might even have a pilot project. And then we also run into some customers that have fully embraced it and have live examples.
All right, we'll give you a few more seconds to answer this poll. Thanks for staying on your toes, guys. So we'll be closing this poll in 5, 4, 3, 2, 1. And let's go ahead and share those results.
Okay, so it looks like 17% of you have no interest in IoT. 83% are exploring IoT. Okay, so we don't have anybody that's actually done a pilot project or has embraced IoT at this point. And that's actually pretty common when we talk to people, because a lot of people in factory actually don't realize that some of the applications that they've done are described as IoT applications. So we'll go into that in a little bit. So here's one of the things we really see is as the number of devices are connected, so in a factory floor, here's just some examples of the types of things that we see that may have been on just an isolated control network in the past, are now connected using an Ethernet connection that eventually connects to the internet. So PLCs, HMIs, industrial PCs, but then all types of sensors and actuators, I/O devices, PLCs, the distributed control systems. And as the number of these devices increases on your network, the complexity of your network also increases. Whereas a few years ago, a handful of devices connected to an unmanaged switch was perfectly fine. But now you've got sensitive control data mixed with maybe video and voice and other data on the same network. There's more of a need for managing the flow of that information, developing cybersecurity, redundancy to make sure that you have uptime. So here's some of the common challenges that we see when we work with our customers in implementing industrial networks. So with IoT adoption, scalability becomes a big issue. As I mentioned earlier, with the number of connected devices expected to double over the next 5 years, being able to plan for that and know that the control systems that we're putting in place today will have the capacity to deal with the increased load over the next couple of years. And so with those increased number of devices comes a need for increased bandwidth, especially as more vision systems and video, high bandwidth type devices are connected to the network. Larger pipelines are needed basically in the network. And as more of the critical infrastructure is connected to a common Ethernet network, industrial cybersecurity becomes a big issue. And that's not just to protect against malicious attacks, but also unintentional attacks. And then the foundation of industrial networks has been, reliability. So that brings us to our next poll. So what is your number one challenge concerning your industrial network? As we work with our customers, we see that one of the key challenges is interoperability. Rarely do customers have the ability to just start from scratch. So you've got, a variety of devices from various eras working side by side that need to work together in order to connect and communicate seamlessly. Reliability is another big concern. As critical control data starts flowing on the network, network integrity becomes critical because you don't want to take down your production line due to a network outage. And then probably more recently, the number one topic we talk to people about is network security. It's a concern either because they've had problems or, you see there's a lot of press about it these days. And the one thing that we see that's pretty ubiquitous across all of our customers is that the need for networking expertise is outstripping their current capabilities. So let's see what you guys had to say.
All right, we got a good number of people voting. Let's get the last number of votes in, and we'll go ahead and take a look at those results. All right, you guys ready? Here we go.
All right. So it looks like 56% of you said interoperability is your biggest issue, with 22% saying maintaining highly reliable networks, and another 22% of you saying implementing and managing security. So here's a survey done by the World Economic Forum. So this was a survey done in 2014 by the World Economic Forum, Industrial Internet Survey. And so basically, lack of interoperability or standards was one of the top concerns, followed very closely by security. Legacy equipment was another big one, and lack of skilled workers was another concern. So, given all of that, as the networks become more complicated, there's more to think about when you're implementing it. We're seeing that people are still, in many cases, just looking at the purchase price of components when they look at the cost of their industrial networks. And as these networks get more and more complicated, there's more and more labor and other factors that play into the total cost of ownership. And so we just wanted to share kind of a representative model that we see when we talk to customers about the different costs associated with their networks. So in addition to the acquisition cost of the hardware, the networks need to be installed, the devices need to be configured. There's a cost of operation as well as maintenance. Probably the biggest one that we talk about is unplanned outages or downtime and the costs associated with that. And then one of the costs that tends to sneak up on people is the cost of support and service. And so now we'll move into some of the hidden costs that we typically see. So in addition to the purchase price, as devices or as the networks get more and more complicated, the time and effort to install and configure and integrate them with their existing systems can be pretty substantial. Again, as that complexity increases, the amount of maintenance to keep the networks running increases. Downtime is absolutely the number one cost that people are trying to mitigate. And then the support and service costs. And so we'll go into those in a little more detail. So when we look at installation and integration, here's some of the things that we want to look at. Is in many cases we're installing this equipment in existing racks or panels. We're seeing probably 3/4 of the expenditures on industrial networks tend to be in the form of upgrades or expansions. So they're not starting from scratch. So they're trying to add devices and capabilities to existing machines, panels, and control rooms. With that, there's typically power supplies that are already run or in those panels. Running additional Ethernet cables. Typically, there's not Ethernet cables running in a lot of those cases, so you've the cost of running new cabling or fiber. And then planning for capacity, whether it's bandwidth or just the number of connectivity ports. Looking ahead and making sure that you're not looking at doing another replacement of those components down the road. And then the two integrations that are most common, the number one is with industrial protocols. Whether that's field bus protocols or some of the Ethernet IP or Profinet. The networks that are currently running in control applications on the plant floor. And then as those devices are connected up through the internet, typically there's some sort of interface with the enterprise. And the security and compatibility with, in order to do that is a big concern. So configuration costs, I throw this slide up just to, this is kind of alphabet soup as far as acronyms associated with networking. But in general, there's four main kind of objectives that most of these protocols and technologies are geared around. So when you go from an unmanaged or plug and play type network device to a managed switch, you're really looking to accomplish one of four things or multiple of these four things. So first is redundancy. Having a self-healing backup path should you have a link or a device failure, so that your network doesn't go down and take your production equipment down with it. As I mentioned before, as you have more and more devices, some of them need higher priority than others on the network. Just tools that allow you to tune the efficiency of the network performance. The third is security. As more assets are on the network, the danger of a breach or increase as well. So having devices and technologies available to you to secure your network. And then finally, how do you manage all that stuff without taking a ton of your time? When we look at operations and maintenance, typically once a network's set up, creating the documentation so that, the people that are faced with running the network from day to day have the information they need to know what the network should be doing. Monitoring that network health and the traffic loads, especially as devices increase. Regular backup of network configurations, much like your laptop or your business systems, having a backup should there be a catastrophic failure that you can roll back to a known working configuration and get you back up and running quickly. And then user account management. As you've got lots of different devices and those all have management interfaces, you want to make sure that only people that have authorization can get in and make changes. So downtime is by far the area that most people are concerned about. And we talked to a lot of different people. This survey here just kind of shows that we see estimates as low as $300,000 an hour to as much as over $2 million an hour for the cost of lost production. So you can see that the cost of an unplanned outage could easily exceed the cost of the initial investment on much of the equipment. And then, of course, there is the cost to repair and replace hardware. And in many cases, we find that the end user customers don't necessarily have on-site staff that are well-versed in the network, so they often need to bring in integrators or technicians to help them. Then service and support costs. We look at warranties, support contracts, firmware updates and security patches, as well as product obsolescence is a big issue. Unlike consumer electronics, where you may buy a device, use it for a year or two, and then upgrade to a new device, and that's fairly commonplace, most of our customers are looking for a 5 to 10 year life expectancy out of the components that they buy. So they want to know that if something should fail during that time, not only can they get it fixed or replaced, but also from a software support standpoint, since a lot of these devices do require security patches from time to time, etc. And then availability of documentation, just making sure that people down the road can find information that they need to keep the network up and running. All right, so that brings us to our third poll. So of the costs we mentioned, which costs are the most significant for you aside from the initial purchase price for your network equipment? And so all
right, let's start seeing those votes. You guys still on your toes? Installation and integration, configuration, operation and maintenance, downtime, service and support. You can ballpark it. I know you probably don't have your calculators out to be able to calculate all of these costs in great detail, but based on the information shared, what's your best guess?
All right.
And this time I promise I won't lose track of the little control that lets me turn the polls on and off. We'll give you a few more seconds here. I got some good responses and one overwhelming choice. So let's go ahead and see what that is. In 5, 4, 3, 2, 1. Here we go.
All right, so it looks like installation and integration is the biggest challenge for most of you. And then operation and maintenance, downtime and service and support would would all tie for second place there. Okay, looks like most of you are fairly proficient at configuring network devices. All right, so let's move on to the real meat of our presentation today, which is the 5 tips to reduce total cost of ownership. So here's kind of an overview of the 5 tips. The first would be to consider alternative cabling options. The second would be to utilize software configuration tools. The third, monitor network through network management software or SCADA integration. Fourth would be design for high reliability. And fifth would be assess long-term support capabilities. So let's go into those in a little more depth. So often when you're installing a new network, there are no network cables or Cat5 cables that are run to where you need it. In some cases, you're installing devices that are a long ways out from where your control center is. So one of the ways that to reach hard to wire to devices is to utilize wireless technology. And a lot of people may be reluctant to use wireless because they think of, the Wi-Fi access point in their home or office. But industrial wireless access points can really be set up, reliably to work as a point-to-point bridge between a fairly remote segment of the network and the main network itself, and often significantly reduce costs by not having to trench and run new cables out to that location. Another way is there is a growing number of devices that utilize DSL or similar technologies to allow you to run Ethernet over existing copper wires. So in this example for city infrastructure, they're actually reusing existing phone lines that are already run to the cabinets that they're installing this equipment in and utilizing that DSL technology to transmit Ethernet. In a factory situation, often it's reusing old serial cables that are already run into the cabinets to run Ethernet over. This can save a lot of time and money for running those cables. When we talk about configuration, we run into 2 types of people. The typical IT expert that's familiar with command line interface, and they generally have a routine pretty much down for configuring devices. But when we talk to most of our customers that are control engineers or not necessarily IT experts, they prefer a user interface that's a little more graphical. A lot of them don't realize that many of the manufacturers offer a configuration tool that allows them to configure multiple devices, from a single PC, often saving up to 10 times the amount of time it takes to commission a network. So once the network's up and running, how do you monitor the network? How can you see what's connected to what? How can you remotely look at the devices, manage them, make changes to the configuration? And how do you track events? If a device fails, you want to know about it very quickly. And how can you look at the performance of your network so that you can make adjustments to increase that efficiency? So network management software is one of the common tools that are available to you to do this. The other would be utilizing your existing SCADA system. Many of the network devices that are out there now support industrial protocols like Ethernet IP or Modbus or Profinet. And if your SCADA system communicates with one of those industrial protocols, then you can often monitor and manage the devices using the SCADA system that you're already using to manage the rest of your devices on the network. So alerts and event logs. A big thing with if you have a problem and you're monitoring it using the SCADA or the network management software, having some sort of alert when something goes down. We talked a little bit about redundancy earlier. Um, this kind of goes hand in hand with that from the standpoint that if you have a failure and your network recovers from that failure through a backup path, you still want to know that that happens so that you can get out there and fix it before your backup breaks. So our fourth poll question: do you currently integrate your networking devices using a network management software or SCADA system?
All right, so let's see those votes come in, whether or not you're using network management software or your existing SCADA system to monitor your network. And we have a couple of choices here. It'll be very interesting to see what the prevalent opinion is, or the prevalent choice is for monitoring your network. All right. And you guys voted quickly on this one. I'll go ahead and close the polls. A few more of you want to get your votes in. And we'll go ahead and take a look at the results. 3, 2, 1. All right.
All right. So it looks like a good percentage of you use, 40% of you use a network management, an industrial network management system, followed by 30% using your SCADA system. Well, that's great. So you're already doing a lot of the stuff we're talking about here. Okay. So the next is reducing the cost of downtime, designing your system for high reliability. And this is, at this point, most of our customers get this and know that there are devices out there that are specifically designed for industrial applications, knowing that, power interference, magnetic fields and emissions, flammable gases, extreme temperatures, humidity, moisture, particulate contaminants, shock and vibration are all things that are typically found in industrial applications. And commercial or enterprise grade equipment typically is not designed to handle that. There are devices, lots of devices out there that are designed specifically for industrial applications, and they're well worth the extra money. When we talk about redundant technologies, when designing a network, designing it in a way that you have a backup path should you have a network failure is a critical portion of the network. So a typical office design would have a hub and spoke or a star topology where you've got one control room with rack mount switches and a single line running out to each port. That gives you a single point of failure, and if that goes down, your whole network goes down. So in an industrial application, typically utilizing mesh, which is more used in wireless. RSTP or STP is another technology. So, the advantages of that is it's an open protocol that almost all switch manufacturers support. But it'll give you roughly, 1 to 5 second response time. So the advantage is it's an open protocol. The disadvantage is it's kind of slow. Then we get into, some proprietary technologies such as Moxa's turbo ring, turbo chain, where you can get less than 20 milliseconds fast healing, but you've got to use one manufacturer's product to get that level of performance. If you're in a situation such as a substation automation, some of the redundant technologies that are starting to emerge there, such as HSR and PRP, can give you zero recovery time. But the downside of that is you're basically creating a complete redundant network, so the costs of implementing that are significantly higher than the other technologies. Cybersecurity, having a plan when you roll out a network expansion or a new network, and we really, when we talk to customers, the 3 main topics that come up are critical device protection. So that's putting firewalls to keep unintended traffic out of your control network. Secure remote access, if you've got a distributed network, utilizing VPN technology to provide encrypted tunnels between your various locations. And for those that have a lot of different sites that they're monitoring, managing all those connections, they're often moving more to a cloud-based VPN connection. So the final one is the cost of support. And this is where we see a lot of people don't realize the cost of support until they need it, until there's a failure. All warranties are not created equal, and we see a lot of situations where people think they're covered and they're not. The warranty's for 5 years, but the product is now obsolete, and there's nothing left to replace it. Access to technical support. Some companies have, you can email in for technical support. Some you can get people on the phone. Some companies charge an annual fee to give access to technical support. So know what those costs up front is a big part of understanding your total cost of ownership. Another big thing is security patches and firmware updates. In a lot of cases, new vulnerabilities are discovered on a regular basis. Hackers don't stay still. They're always finding new ways to get into industrial networks. And you want to make sure you're choosing a vendor that's keeping up with those things and has a response team that can address security vulnerabilities as they come up. Long-term availability is another thing that comes up on a regular basis. As we talk to customers, we find that a lot of the upgrade plans that they're doing are a direct result of obsolescence of a product that they're currently using. And, so if that product's been on the, you've been using it for 5 or 10 years, it's probably acceptable to say, all right, it's, we may need to replace it. But more and more we're seeing where devices are going obsolete in a shorter period of time. And, so they're checking with your vendors to make sure that the products that you're looking at using have a life expectancy and support to go along with that is important. And then online documentation and troubleshooting tools is another thing that can significantly decrease your cost of support. So just to wrap things up, we've covered some alternative cabling options to consider that could potentially save you some money. Some software tools that can help you reduce the amount of time it takes you to configure and get your networks up and running. Some different ways that you can integrate your network with either your SCADA system that you're currently using to monitor the network, or through utilizing industrial network management software. We covered how designing for high reliability can dramatically reduce your cost of downtime, and just some things to look at as far as support, so that you first know the support level that you're going to need should you have a problem down the road, as well as what the costs are associated with it. And that concludes today's webinar on total cost of ownership. At this point, if anyone has any questions.
All right. So we are now at the live QA part of the broadcast. So don't be shy. Start submitting your questions about reducing network TCO. We're going to answer as many as we can live during this broadcast, and we'll handle the rest in a written follow-up email. So let's go ahead and start with some questions that were submitted earlier this hour. We have a question from Dan. What is the difference between an industrial NMS and the enterprise NMS my IT department uses? Rich.
All right. Well, that's a good question, Dan. So while both serve pretty much the same purpose as far as monitoring and maintaining the network, there are a couple of important differences. First of all, an enterprise network management system is going to visualize the network from a logical link perspective, whereas an industrial network management system is going to show you the physical connections between the devices. And this makes it much easier to troubleshoot hardware problems in the field, and it's also more consistent with how SCADA systems show connections. The second main difference is event alarms and alerts. With an industrial system, they're real time because you need to know immediately if there's an event that could impact the reliability of the control network. Whereas with many of the enterprise network management systems, they're batched or they'll pull the system from time to time to see if there's a problem.
All right, thanks very much, Rich, for that answer, and Dan for that question. Keep those questions coming in. Let's move on to another question here from Mark. What are some of the troubleshooting tools available for finding network problems? Rich.
Thanks, Mark. So there are some common IT tools such as packet analyzers like Wireshark or Wi-Fi sniffers like WiSpy that are very helpful if you know how to use them. But more often the tools that we see industrial control engineers are finding more useful are some of the built-in snapshot tools and event recorders in the available industrial network management software. These basically allow you to take a snapshot of the network when it's healthy and then quickly find where things have changed so you can pinpoint problem areas quickly. Event recorders work very similarly, but they're more like video. They record the same type of information as far as the current configuration and status of the network, but they can be played back so that not only can you pinpoint where there's a problem, but also what time it occurred so that you can cross-reference other processes that may have been running at the same time to find the root cause.
All right, thanks very much, Rich, for that answer, and from Mark for that question. We have another question, Rich, here from Kim. My network is distributed over many locations, separated by hundreds of miles. Can I use configuration, troubleshooting, and management tools from a remote location?
Excellent question, Kim. So in short, the answer is yes. Most of the tools that I've seen can be used from a remote location. In fact, the value of these tools is significantly more if you're in a situation like that. So in order to get the full benefit of a network management system from a remote location, that location would have to have full-time access to the network management server. So whether that server is located in the same place as the network you're trying to monitor, or if you've got a full-time VPN connection between the server and that location, that allows you to full-time monitor the network. But even if you don't have that, and many of the customers we talk to will, kind of establish a connection to a remote location and then run the tools locally over that secure connection, and either configure or troubleshoot the remote network utilizing that. So, yeah, good question. Thanks, Kim.
All right, thank you, Rich and Kim. Here's another question. Rich, are there any available tools or checklists or worksheets that a customer could use to calculate total cost of ownership for their industrial network?
Sure. Actually, we've got one on our website that we can. I'll send a link out in the follow-up email from the webinar. But yeah, it takes a look at some of the common costs that we look at, gives you an opportunity to plug in some of your own values and then actually calculate a total number.
Thank you very much, Rich. I think we have time for another question. So from Tony, Rich, what are the estimated support costs that other customers that you've encountered have? What are the estimated support costs that other customers have encountered? Are there any numbers that you can provide for comparison purposes?
Yeah, I think we see two things pretty frequently. We see customers who have installed devices that don't have the support that they need when they have a problem, and so they wind up replacing it. So often that cost is the cost of replacing that component in a downtime situation. The other is some will go out and work with manufacturers that will offer a support and service contract. So these contracts typically will cover access to their technical support people, documentation. We'll also give you access to firmware updates and security patches, but they're typically anywhere between 6 and 20% of the cost of the components on an annual basis. So you got to take that into consideration.
All right, thank you very much, Rich. We had one more question from Michael. Would it be accurate to say that in general, unmanaged switches versus managed switches, that managed switches tend to offer a superior TCO for most industrial networks?
Well, I think we see that there's certainly a place for both. We're seeing more and more conversion from unmanaged switches to managed switches as the number of devices grow. For a lot of the reasons I mentioned, that just the increased bandwidth, unmanaged switches typically do not give you the ability to secure that section of the network. There's no ability to prioritize traffic. You don't have any visibility, through a network management system as to what's going on with the traffic through an unmanaged switch. So for the core of the network or any of the parts of the network that have critical control data, where you potentially have access to critical devices, we're finding people are moving to managed devices. But we'd still see, adding peripherals at the edge of a network. There's still a place for an unmanaged switch where you just want that plug-and-play simplicity, and you've got some sort of protection between that extension of the network and the main core of the network.
All right, thank you very much, Rich. Great question, Michael. I'm afraid that's all the time we have for questions. I want to thank Rich for the great information that he shared today on lowering the cost of industrial network TCO, and to everyone here for attending and asking great questions. Rich, any final words?
No, thanks for coming today.
All right, hope you enjoyed our presentation. Thanks again for tuning in, and have a great rest of the week.